In this video, we are going to be looking at evaluating algebraic expressions. Before we get into the actual math of it, I wanted to talk a little bit about the language there and make sure we're tracking as far as what all those words mean. First of all, evaluate is a word that we've already discussed, and that just means finding the value of something. So if you evaluate a person, you determine their value. If you evaluate a math expression, you determine its value. Math is a little bit more straightforward than evaluating people, but it's the same idea, same use of the word. So as we've seen, if we have 2 to the 4th, the way we would evaluate it is just to say that it equals 16. Now we'll look at the word algebraic. Algebraic is just saying that there's going to be variables involved. So instead of just having all these numbers to grind down, we're going to be throwing some variables at you. For example, 2 to the 3rd minus 3 times 5 is something we've been looking at. Doesn't have any variables, we wouldn't say it's algebraic. X to the 3rd minus 3y is an algebraic expression. So generally, we don't actually keep this word algebraic. We usually will just say evaluating expressions, or instead of saying algebraic equations, we just say equations. But if it has variables in it, it's going to be algebraic. We just tend to leave the algebraic off because it sounds a little too snooty. And then as far as expressions go, expressions in math are the things that don't say anything, is one way to think of it. They're not a complete problem. So, for example, in English, an expression would be something like, wow. So it's just an expression, but it's not a complete thought, it's not a complete sentence. It's just something you say to express emotion, I suppose. So in math, the same thing is expressions they don't make a complete statement. They're not a complete sentence. For example, 2x would be a math expression. 2x equal to 5 would be an equation, which is a complete sentence because the equals is a verb. Sometimes it's said as is. 2x is 5. And so it's a complete sentence, and you can actually do stuff with it. You can determine it. It's a complete thought. 2x kind of feels like it's incomplete. There are other things that are not expressions that we'll be working with in this class. One of them is inequalities. So instead of an equal sign, you would have a greater than or a less than or something like that. And then we'll also be working with something that's called functions, and those are not expressions either. But expressions are, in general, the ones that they don't have equal signs, they don't have inequalities, and so on. Alright, so that's the idea of an expression, and so now we're being asked to evaluate an algebraic expression, and the question becomes, how do we do that? Because with something like 2 to the 3rd minus 15, we can just grind through those numbers and figure out the value that are represented by that expression. So 2 to the 3rd is minus 3 times 5 is 15. And so then 8 minus 15 would be -7. So we can evaluate that because each little piece has value, so we can figure out how those combine to one value. But how do we do that when variables are in the way? We've said we can't. All we can do when variables are in the way is simplify it down as much as possible. But you can't evaluate it, and now we're being asked to evaluate algebraic expressions. Well, if someone came along named Bob, and he said, hey, I've got a 2 right here that you can use for that x, and he whips something out of his other pocket and says, and I have a 5 that you can use for that y, then we could take this 2 that Bob is offering and substitute it in for the x, and we could take the 5 that Bob is offering and substitute it in for the y. And that would give something like 2 to the 3rd minus 3 times 5. Now everything has value, and we can grind it down to a single value. And this happens to be the same thing that we were seeing over here. So we've already done that, but that's the idea, is you cannot evaluate an algebraic expression unless you're given values to substitute in for your variables. And that's what we will be looking at, is problems where we're given an expression, but we're also given values to substitute into that expression. Let's look at some full-fledged examples. Alright, so on these problems the directions will look something like this. Evaluate the following expressions for x equal to -3. So in that way they're handing you a value. Alright, so for A we'll look at the expression x plus 4. And just wherever you see an x, you take it out, throw it away, and you stick a -3 in that slot. That'll end up looking like this. -3 plus 4, and notice how I've wrapped the -3 in parentheses. Whenever you substitute in a value into an expression, it is good to wrap it in parentheses. It's not always necessary, but it's good to do it as a habit so that when it is necessary, you have it taken care of. So here, -3, whether those parentheses were there or not, the expression is saying the same thing. So -3 plus 4 gives us a positive y. So that one was just a straightforward example to get our thinking going in the right direction. Now let's look at some that are a little trickier. Now we're going to look at some that have some curveballs in it. First of all, b 4 minus x. So again, we're just going to take the x, throw it away, and replace it with the -3. But we do need to be careful here. When we're replacing it, we are just taking out the x, and we are replacing it with a -3. Alright, what that ends up looking like is 4 minus a -3. So what I'm trying to emphasize here is the minus from the problem is still with us when we substitute in the -3. It's all too common that when students substitute in the -3, it overlaps with that negative, and they say it's just 4 minus 3. But we need the minus, because it's in the original problem, and we need the negative from the 3. You can't overlap those and double account for them. So we have 4 minus a -3, which is really just 4 plus 3, and so that's going to give us a 7. Let's look at part C. Okay, for C, we're going to look at x squared plus 5. So let's substitute our -3 in. So we get -3 squared plus 5. Notice how I've wrapped it in parentheses. This is one of the places where the parentheses really matter a lot. It's not -3 without the parentheses squared plus 5. We've talked about how those are different things and they work out to be different values. So the parentheses really do matter to keep the number you substituted in grouped as one value. And depending on the expression, that can look different in different places. So here, since it's the quantity of -3 squared, that's going to come out to be a positive 9 plus 5. And then 9 plus 5 is 14. And we're done. So that's the idea. You take the value, you put it in for the variable, being sure to wrap it in parentheses, and then grind out the resulting problem to a single value. We're going to look at one more example that involves having two variables to work with. So here our directions basically say the same. Evaluate the following expression for, but now we have two values, x equals -2 and y equal to 6. Let's evaluate those in this expression, xy minus y divided by x. So this is the same idea, you just have to make sure you get the right variables in their correct slots. So the x's will get traded out for a -2, and the y's will get traded out for the 6. And that ends up looking like -2 times 6 minus 6 divided by -2. And then once I get all that substituted in, it becomes what we've been working with the order of operations, right? So we need to do the multiplying here and the dividing first, and we can do those at the same time because they're separated by this minus. So whatever values come out of that multiplication and that division, that's what we'll be subtracting. -2 times 6 is a -12, and 6 divided by -2 is a -3. And notice also how I brought the minus straight down. So the 6 divided by -2 produced a -3, but then I also brought down the minus that was from the original problem. Again, this is a place where sometimes you can lose a negative by double accounting for them. So what we have there is minus a -3, which is really just +3, so -9. And we're done. So that's the idea. Substitute the values out, and then just be careful about what order you do the operations in, and keeping track of all those negatives, not letting yourself double account for them. Alright, give some problems like that a try and see where you end up.